Where do I go?
There should be like, okay, yeah. And then you have to go click on chapter 4 because we're in chapter 7. So go up and click on the chapter 4.
7 what?
715.
Okay. What kind of calculator do you have, Lachlan?
Uh, the Texas is
Either probably a TI-84 or a TI Inspire.
it's a TI-84.
You know how to change between degrees and radians on it?
Yep.
Okay. It's actually easier to change on that one than it is on the Inspire. The Inspire is amazingly difficult to switch between degrees and radians. Okay, go ahead and do that on A. Find the sine of 60 degrees. Tell me what you get.
0.866.
And now switch to radian mode and find the sine of pi over 3. And you have to make sure the pi over 3 is all within the parentheses. So it should say this. In other words, you got to do this.
So sine of how did you get to that?
You have
So
to put it in parentheses. So it's the pi key divided by 3, like that. You have to make sure you're in radian mode.
yeah, I am.
Okay? What do you get for the sine of pi over 3?
0.866.
Same answer.
Yeah.
Explain why your answer should be the same. Well, if I convert 60 degrees, what's the conversion factor to get it to radians? Either pi over 180 or 180 over pi. Which one is it?
Is it 180 over pi?
No, it's pi over 180, and here's why. It's the 180 that has the degrees, and you want those degrees to cancel because that is in radians, and we want our answer to be in radians. So we get this. Okay? In other words, 60 degrees is the same as pi over 3 radians. Now, here's the thing. Radians are really a particular unique type of unit, and they are rarely expressed. In other words, if you say 60 and you mean degrees, you got to say degrees. But if you say pi over 3, you don't have to say pi over 3 radians. It is presumed that you mean radians when you do not say degrees. It doesn't have to have a pi in it. If I said something was 5, that would be presumed to be radians. So if it's in degrees, you have to say degrees. Anything else is presumed to be radians. So now tell me what the sine of pi over 4 is. Since you're in radians, you don't have to switch.
.70.
So, what's the same angle as pi over 4 if I wanted to look it up in degrees? So here we have pi over 4 radians. What's the conversion factor? It's either pi over 180 or 180 over pi.
Pi over 180.
Remember, you're trying to cancel the units. In other words, when I say convert that, you got to end up in degrees. Okay? Well, the only way you're going to end up in degrees is if the radians is in the bottom and the degrees are in the top. Now what's the conversion factor?
180 over pi.
Exactly. In other words, the degrees always goes with the 180. This way the radians cancel, you end up with degrees, and there's the pi over 4 radian, or excuse me, 40, you end up with 45 degrees. In other words, pi over 4 radians is 45 degrees. And if you put your calculator back in degree mode and do the sine of 45, you'll get that same answer, 0.707.
Yep.
I assume that's the last one on this page. Yeah.
Yep.
Ooh, this is weird. I got a weird thing here. Hold on. All right, that's better. So, when it says express your answers both exactly and as decimal, your calculator is only going to give it to you as decimal. So do the sine of pi over 4 again. Make sure you're in radians. That's a radian measurement of an angle, pi over 4.
.707 or 0.70.
Yeah, 707 is better. Now, how would you express that exactly? Your calculator is not going to help a lot here. I don't think there's any way you can take that decimal and convert it to a proper irrational answer. Here's what we need. We need this special triangle because we're talking about a 45-degree angle, are we not?
Yep.
Okay. And with trig, the only thing you care about are the ratios. You don't care if this triangle is labeled 1, 1, square root of 2, or it could be 2, 2, 2 square roots of 2. Or it could be 10, 10, 10 square roots of 2. Trig is all about ratios. So tell me, based on this right there, what the sine of 45 degrees is. SOHCAHTOA.
0.85.
Don't use your calculator. Read it off the triangle. Your calculator's not going to help you. It's not going to give you the exact answer. You'll understand once we get it. So,
Okay.
read it off of that triangle. Sine is opposite over hypotenuse. What is that? What's the opposite side to 45?
Um,
There's the
oh,
there's the 45-degree angle. What's the
yeah,
measurement of the side that's opposite that?
1,
Over the hypotenuse. What's the hypotenuse?
root 2.
So there's your exact answer. Now, if your teacher wants you to rationalize that, that's fine. Some trig teachers want you to, others don't care. In other words, that's perfectly acceptable to most of the trig teachers. But if you're dealing with a trig teacher that always wants you to rationalize it, if it's irrational in the denominator, then that becomes root 2 over 2. That is the same, whether, in other words, both of the things I have circled are the same answer and they are both exact. The 0.707 is the decimal approximation of it. But notice that you were not able to get the exact answer from your calculator. That's an important lesson, which means the two triangles you absolutely must memorize are the 45-45 and the 30-60. And the 30-60 is 1, root 3, 2. So, based on that, what's the sine of 60 degrees? The exact number.
Would it be 2 over root 3?
Okay, first of all, do it in the order that you see. What's the O stand for?
Opposite.
What's opposite of 60?
Oh, okay, root 3.
Over the hypotenuse. There's always a hidden over right there. Okay.
Yeah.
What's the hypotenuse?
2.
There's your exact answer for the sine of 60 degrees.
Okay.
Now, if you turn that into a decimal, I think that's what becomes 866, which is what you got on the previous problem. All right, so let's look at the next problem. The sine of 2 pi over 3. Now, you had the unit circle?
The what?
Have you had the unit circle?
I don't think so.
This is the unit circle.
Oh yeah, we have a bit.
Okay. Which quadrant is that angle in?
How are you supposed to tell without like a degree?
Well, you kind of want to eventually be able to think in radians. And I know this is difficult to do. What course are you taking right now?
Algebra 2 trig?
Okay, so you're taking trig. In other words, if you were taking just Algebra 2 and this was your 1 week of trig, you don't get the unit circle. But because you're taking trig and you're going to be taking it the whole semester, you need to learn the unit circle. Absolutely. If I have a new trig student and they don't know where to begin, I always begin on the unit circle. Okay? That's quadrant 1, 2, 3, 4. Counterclockwise, notice. Not clockwise. Counterclockwise. This is 90 degrees. This is 180. This is 270. That's back to 360, which is also 0. Now, it's useful to put these also in terms of radians. That's also pi over 2. This is pi. This is 3 pi over 2. And that's still 0. Now, here's a really good thing to realize. Those 4 right there. What's the same about each one of them? What's the same about that, 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 and that?
They're all in the first quadrant.
No, those two numbers multiply to 180. Those two numbers multiply to 180. Those two numbers multiply to 180. Those two numbers multiply to 180.
Okay.
Now, I could have used the conversion factor to turn 60 degrees into pi over 3. So it's not really a different process. I'm still using the conversion factor. It's just this is going to make your life so much simpler if you can realize this. And this is only true when pi is in the numerator. In other words, if it's 2 pi over 3, it's not 60 degrees. But if pi over 3 is 60, what is 2 pi over 3?
Would it be 120?
Exactly. What's 4 pi over 3? Pi over 3 is 60. So what's 4 times that?
240.
Yeah. Notice this is a little easier way of converting radians to degrees. It's really easy. Much easier than this method. Well, that method converted degrees to radians. But whenever you're converting radians to degrees, this new method that I just kind of taught you saves you a whole lot of time. And it's all based on having a numerator that's pi only. Okay? So, we did we do that one? Yeah. We didn't do this one yet. First of all, you need to tell me what quadrant that's in. That's the first step.
So would that be in quadrant 2?
Correct. Because it's between pi over 2 and pi. In other words, 2 pi over 3 is between pi over 2 and pi. So it's second quadrant. Now, my first goal is to turn it into the equivalent first quadrant angle. I want you to do all of these like this. Okay? And the way I'm going to do it is there's one more thing you have to memorize in the second quadrant. And that's to turn it into the equivalent first quadrant. We're going to either do that or this, depending on whether the thing has been given to us in degrees or radians. Well, what's this in?
Degrees.
What's that in?
Radian.
So we're going to use that. So the angle that we really want to figure out is not 2 pi over 3, but pi minus 2 pi over 3. Well, what's pi minus 2 pi over 3? What's that equal to?
Would that just be pi over 3?
Uh-huh. So here's what I do. I say the sine of 2 pi over 3 is going to be the same numerical value as pi over 3. And I put it in parentheses because it's not the same as pi over 3. It's just the same absolute value. Well, pi over 3 is 60 degrees, right? 3 times 60 is 180. If you refer back to this special triangle, it's 1 opposite the 30-degree side, square root of 3 opposite the 60, 2 is the hypotenuse. Tell me what the sine of 60 is. Not with your calculator, but from that triangle.
Pi 3 over 2.
Square root of 3 over 2.
Oh yeah, sorry, square root of 3.
Opposite side, square root of 3 over 2. So that's the numerical value. Now the only thing we have to figure out is whether it's a plus or a minus in front of it. And to that, we're going to use this. All students take calculus. I don't know if they've taught you this or not, but here's what it means. The A means all 6 trig functions are positive in the first quadrant. The S means only the sine is positive in the second quadrant. Well, not just the sine, but its reciprocal, which has to have the same sign, so the cosecant also. In the third quadrant, the only thing that's positive is the tangent and its reciprocal, cotangent. And in the fourth quadrant, the only thing that's positive is the cosine and its reciprocal, secant. So, which quadrant are we in? 2 pi over 3?
Quadrant 2.
What's its plus or minus sign? Plus or minus? When we are talking about the sine function.
Plus.
That's what goes there. That's the answer. That's the exact way I want you to do every single problem like this. Because if you do every single problem exactly like this, you can give the entire unit circle, which I'm sure they've told you they're going to want you to memorize. If they haven't told you yet, they do.
Okay.
I want you to memorize every single one of the common angles, starting with pi over 6, which is 30 degrees. And they want you to know pi over 4, which is 45 degrees. Then they want you to know pi over 3, which is 60 degrees. Then they want you to know 90. And then they want you to know every multiple of 30 all the way around. So there's 16 different angles they want you to know all 6 trig functions of. And this method right here is the one that will allow you to do it step by step, no matter what the angle, as long as it is a multiple of 30 or 45. That's all that it takes. Okay? So, now, I left a couple of things off this chart. Let me put them on there, and then I want you to take a picture of this thing if you don't have it, because you want to memorize every single thing that's on here. Let me erase the absolute unnecessary stuff, because you should know that if sine is positive, then cosecant has to be positive. What this is a way of converting your angle to a first quadrant angle. That's always the first step. Well, what if you're in the third quadrant? Well, this changes to theta minus 180 or theta minus pi. when you're in the third quadrant. When you're in the fourth quadrant, it's 360 minus theta if you're in degrees, and that's 2 pi minus theta. So let's just go through this before we go further, because I feel like I can teach this to anybody. You give me an hour, you're gonna walk away from this with a great talent, which is to be able to tell all 6 trig functions no matter where they're at. So let's try an easy one. What is the sine of 210 degrees? First step, tell me what quadrant it's in.
Quadrant 3.
Okay. Second step, what is the equivalent first quadrant angle using, that formula right there?
Would it be 60?
Okay, what's theta?
Oh, theta would be...
Theta is this angle right there. So what's 210 minus 180?
30.
So that's the equivalent angle that we're looking at.
Oh, okay,
Now,
okay.
tell me what the sine of 30 degrees is. Looking at that triangle.
It would be 1/2.
Correct. And then final step is tell me what the plus or minus sign is. We're in the third quadrant. Remember, we're not in the first quadrant. The first quadrant gives us this number, but the quadrant that it's in tells us its plus or minus sign. What is the sign in the third quadrant?
Minus.
Correct. Now you're done. That's what the sine of 210 is. Okay? Let's just reinforce this a little bit. There's nothing more important than this. And in fact, they probably do reinforce it with the next bunch of problems, but I've done this long enough that I can make up some good ones. Trust me. Tangent of 225. So, first thing, what quadrant?
3.
Second thing, what is the equivalent first quadrant angle?
45.
So we're looking at this triangle. And what's important to remember on these two triangles are the dimensions. Nothing else, just the dimensions. Tell me what the tangent of 45 is.
Would it be 1/√2?
SOHCAHTOA. SOHCAHTOA. The TOA is opposite over adjacent.
Oh, so 1/1?
Correct. Now, the last step is to put the plus or minus sign on it. What is it?
Minus.
Quadrant are we in again?
3.
Which one's positive in the third quadrant?
Oh, okay, plus.
Correct, because we are talking tangent. Tangent is what is positive in the third quadrant. So the answer is pi. Excuse me, that pi was the label for that axis. The answer is 1. That's how you do it.
Okay.
So everything that you have to memorize, unfortunately, it's not so easy because I've written over other writing, but mainly it's that unit circle. Notice I don't even have the circle on there. That's because you don't need the circle to memorize it. What's important to memorize is this 180 minus theta if you're in degrees, which is the same as pi minus theta if you're in radians. Third quadrant, just reverse them. Instead of 180 minus theta, it's theta minus 180. And the fourth quadrant is always twice the second quadrant. So if the second quadrant is 180 minus theta, fourth one is 360 minus theta. And then remember that all students take calculus. Again, going counterclockwise. And that'll tell you the plus or minus sign of all 6 trig functions in all 4 quadrants.
Wait, so in that quadrant, if it's one of those letters, then it is positive?
Yes, that's the only thing that's positive in that quadrant. In other words, in the third quadrant, tangent's positive, sine's negative, cosine's negative. Now, obviously, if tangent is positive, well, tangent is the reciprocal of cotangent. So if tangent is positive, cotangent has to also be positive. It's just that you should be able to figure that out, and they want to put as little information on this chart as possible. So the reason they have you memorize the all students take calculus is because that's not a lot of information. So we don't generally label this graph with their reciprocals. You just have to know that if tangent's positive, then cotangent's positive. Or if cosine's positive, then secant is positive. Okay? So everything you see over here, memorize. And I've labeled everything in both degrees and radians. Well, this is 180. And that really will allow you to answer all of the following questions that one might ask. What is the sine of 300? What is the cosine of 135? What is the tangent of 330? What is the secant of 45? In other words, no matter what trig function, as long as that angle is a multiple of either 30 or 45, this method is going to allow us to come up with the exact answer. Heck with this decimals. Nobody wants it in decimal answer. Nobody. Very shortly in your class, they will not ask you for the decimal answers. They will only want the exact answer. For one thing, they know you can get the decimal answer by just putting it in your calculator. So that's no great feat. That doesn't teach you anything. Whereas to get the exact answer in radical terms, you have to go through this process. You have to memorize this circle over here on the right, and you have to memorize those 2 triangles. Between SOHCAHTOA, this triangle, and this unit circle, here I'll even put the circle in it, that'll answer any question one can ask you about any of the 6 trig functions. So you might want to pull out your camera and just take a quick picture of what I have on the right side here, and maybe those 2 triangles. Not all down here. You don't need, those are just examples of what we could answer now. But everything else on that page, you really, remember trig is just a lot of memorization. And it starts right here. Okay, you ready to go on?
Yep.
I'm going to have to erase this to go to the next section. My computer is abnormally slow today by like a factor of 4. Look at how long it's taking everything to come up. Just a second. There we go. Finally. All right. What's the zero product rule tell us? What does that mean?
Oh, I forgot.
Most important rule in algebra, all of algebra. Look at what I've circled. So what would the zero product property mean? How would it be relevant here?
Equals 0.
What does that mean? If I got 3 things, I'm multiplying that times that times that, and I'm getting 0. What has to be true?
X is 0.
One of those 3 things has to be 0.
Yep.
In other words, you cannot produce a 0 if one of them is not 0. You can't find 3 numbers that multiply together to equal 0 unless one of them is 0. So the way we solve it is by setting all 3 of them equal to 0. So we've got either x is 0 or 2x minus 1 is 0 or x minus 3 is 0. With me?
Yeah.
Now we solve each of the other ones. I don't need to solve that. That's one answer. I got to solve this one for x. That gives me x equals 1/2. It's another answer. Then I got to solve this one for x. That gives me x equals plus 3. There's your 3 answers. If I said A times B times C times D equals 0, what has to be true?
That one of those is 0?
Yes. Now, only one. All 4 of them could be 0, but only one has to be 0. So even though in this first problem here, we really could only truly say that either x is 0, or it's 1/2, or it's 3. But it turns out that if we plug all 3 of those solutions into the original equation, it's true for all 3. Now, that's not always the case. Occasionally, you will get an extraneous answer that is not true when you plug it back in. And if that's the case, then you run that one's not true. Because when I plugged in 3, it wasn't an equation anymore. But in this case, 3 is true. Because when you plug in 3, that's equal to 0. And as long as one of them is equal to 0, the product of all 3 of them is equal to 0. So let's look at B. I don't have any wiggle room today, Lachlan. I got to go exactly at 4. I have a 4 o'clock.
Okay.
So B, we don't have the product of anything, right? In other words, A was pretty simple because we had 3 things multiplied by one another.
Yeah.
Well, B, we don't. We have 3 things added together. So what do we have to do? Tell you what the right answer to that question is in algebra, at least 50% of the time when somebody says, what do you have to do? The answer is factor it.
Okay.
Okay? So, and the reason that's the answer is if I can take the sum of those 3 things and turn it into 2 things that are multiplied together, now I'm back to the situation I had over here, where I've got three things multiplied together, therefore I can solve it directly. Well, first of all, I got to factor it. Hold on, I just noticed that this was a cubic. It's okay. Is there a greatest common factor there?
X.
Okay, so let's do that first. Always do your greatest common factors first. What's left?
The 2.
Okay, the way to tell what's left is by dividing every single term by your greatest common factor. Divide that by x, divide that by x, and divide that by x.
Okay.
So what's left here?
2x squared.
About the second term, what's x squared divided by x?
X.
And what is minus 3x divided by x?
Minus 3.
Okay. And notice that is a quadratic. And almost certainly we can factor that. Remember, all of this is multiplied together to 0. So again, once we factor this quadratic, we're going to have three things multiplied together equals 0. And guess what? No, it's not this. I thought it was the same. I thought that was going to be the answer. So let's start. How do you factor this quadratic? What's the starting step? Split that up. Always the starting step. What
Yeah.
two things multiplied together equal 2x squared?
2x.
And
X.
there you go. That's step 1. Step 2, what are the signs? Both signs. And I know that because of that negative sign that's in front of the 3. So what do both signs have to be?
Minus.
Opposite or the same?
The same.
If they were the same, wouldn't that be a plus sign? Since the last step in FOIL is to multiply your two numbers together?
Oh, so opposite.
Got to be opposite. So it's either plus minus, but in this case, it could be minus plus also. And they're going to be different because this has a coefficient of 2, this has a coefficient of 1. However, there's not very many factors of 3. We're dealing with 3 and 1. That's it. So let's start experimenting. Let's try 3 there and 1 there. Does that produce my proper middle term?
No.
Actually, it does.
Oh, it does.
Yeah. 3 times x is plus 3x. Remember, you're only multiplying the inside and the outside. That's minus 1 times 2x minus 2x. Add them together, you get plus 1x or just plus x. That is our proper middle term. In other words, we had 4 choices and we accidentally hit on the correct one immediately. That's good. That's going to happen every now and then. Now, so I don't need that minus sign. I don't need that plus sign. In other words, my answer is 2x plus 3 and x minus 1. So, what are my 3 answers?
X equals 0, 3 halves.
Positive or negative?
Negative. And 1.
There you go. That's how you do it. And that's
Alright.
why the zero product property is the most important property in all of algebra, is because you start out with something that you can't do anything with. There's no way to take the sum or difference of these polynomials, have it equal to 0, and solve it. No way to solve it. The only thing you can do is to try to turn this in to 2 or 3 things that are being multiplied together instead of being added or subtracted. If they're being multiplied together, then we can always apply the zero product property. Okay, I don't know. Let me have a quick peek and see if we got time to do one more. The speed of my computer, I doubt it. I seem to be in molasses mode.
It's okay, we can end now.
Okay, this is getting into logarithms.
Yeah.
We're going to need to use logarithms to solve these. And the reason is, we don't need to end just quite yet. I won't do these, but it's important that you understand why we need to use logarithms. Every one of them is not an algebraic equation. Every one of them is an exponential equation. And the reason is the variable is in the exponent. The variable's in the exponent. The variable's in the exponent. Whenever you're looking at an exponential equation, means logarithms are required. You can't solve exponential equations with algebra.
Okay.
Okay? All right, Lachlan, I'll talk to you next time.
Alright, thank you.